Hi guys. So for today's lesson, we're going to be dealing with conditional statements. So what do I mean by a conditional statement? It's a statement that considers the probability of an event. So we're dealing with probabilities, but we're given that another event has occurred, that it definitely has occurred. So an example is, say if you're given that a dice will roll an even number. Like this is a certainty, it will happen. What's the probability with that sort of condition that an even number will roll? What's the probability that a 4 is rolled? Okay, so the way that we like to write this sort of conditional probability where we're given that an even number will roll, it looks something like this. So we can see that we've got the probability of a 4, like we want to know what the probability that a 4 is rolled. Given this line here, that means it's a conditional statement. After the line shows you what conditions being placed on this question. So we're given that it's an even number. That's definitely going to be the case. So when you're finding these probabilities, you're trying to figure out, okay, well, how many ways can we get a 4? So up top, how many ways can we get what we want, our desired result? So there's only one 4 on the dice, so that means there's going to be a 1 up the top. But we're given that it's an even number, so all we have to think about is how many different even numbers are there. Well, on a dice, there's 2, 4, and 6. They're your even numbers, so there's 3 different numbers there. So that's going to be on your denominator. So your answer is 1/3 for your probability for this question. Now, when you're dealing with these conditional probability questions, this is a nice general formula that you can use. So the probability of A given B, that's how we say it. We're given B, that's our condition, B. Up the top is going to be the number of elements in A and B. And then down the bottom is going to be the number of elements in B, because we're only concerned about how many different things are in B, because we're definitely given B. Okay, so let's give a few sample questions a go. So consider the following Venn diagram. Determine the following probabilities. So here we've got the probability of A given B. So the idea is we're given B. So that means we have to be in the circle of B. We have to be inside here. We can literally blank out these numbers here. We can pretty much get rid of them and only focus on these ones right here. So let's have a look. So we got to think the probability of A. So how many of these parts here are in the circle A? Well, only these 10. These 10 are definitely in this A circle, which you can see here. So up the top is going to be my 10. I want the probability of getting an A. Out of the total here, well, in B we've got a total of 18, 10 plus 8. And that gives you your 18. So you're going to get 10 out of 18, and that simplifies to 5/9. So that's your probability in simplest form. Okay, so moving on. What about this one? The probability of B given A. So that means we're definitely in the A circle only. So if I highlight that A circle, because we're given that it's in A, I can literally just get rid of these two numbers. I'm only concerned with what's in A. Now, what's the probability of getting something in B in these numbers here? So how many of these numbers are in B as well? So 10 out of the total numbers here in A, which is going to be 17. So 10 out of 17 is your final answer for that question as well. Okay, moving on. The probability of not A given that it's not in B. So one way to think about it is to come back to your Venn diagram and think, okay, we're given that it's not in B. So what parts up here are not in B? Well, we pretty much just don't want the stuff in B. Let's get rid of everything that's in B. So that's in B, we don't want it. That's in B, we don't want it. So literally everything in the circle B vanished, and we're just dealing with these two numbers here. Okay, so these are the numbers that are not in B, the 7 and the 5. Okay, we want the probability that they're not in A. So look at these numbers here. Which numbers here are not in A? Well, these aren't in A, so those are the ones we want. We want those 5. So our answer is going to be the 5 out of the total, which is the total of 12, 5 and 7. So 5 over 5 plus 7, that gives you 5 over 12. Final answer in simplest form. So hopefully these sorts of strategies will help you out. You just got to think these sorts of think these nice and slowly. Think these through nice and slowly. Okay, question 2, a bit of a wordy question. So, from a group of 15 hockey players at a game of hockey, 13 players played on the field, 7 sat on the bench, and 5 both played on the field and also sat on the bench. And we're selecting a hockey player at random. So a hockey player is chosen at random. Okay, we're going to let A be the event the person played on the field. So that's what A is. So if you're in A, it means you definitely played on the field at some stage. And B is the event that the person sat on the bench at some stage. Now, a really important thing to notice here is that we've only got 15 hockey players. There's only 15 people here. And they're saying that 13 played on the field, 7 played on the bench, and 5 both played on the field and sat on the bench. Notice how our 13, 7, and 5 add up to give way more than the 15 players. And the reason is because like some of these 13 players are included in these numbers as well. So you could be like, say for example, you sat on the bench and you also played. So say if you were one of these 5 people that did both, you're also part of these 7 and you're also part of these 13 because you sat on the bench and you played on the field. So like, don't get confused. Don't feel as though there's like 25 players in those 3. Though some of these numbers are considering the same people. So just remember that there's 15 players in total. That 15 will help you out a lot. Okay, so let's determine the following probabilities. The probability of B given A. So we want to find the probability of B. So what's the chance that a person sat on the bench, if we're picking a random person, given A, given that the person played on the field. So what's the chance, so in words pretty much, what's the chance that the person sat on the bench given that he was a person that played on the field? Okay, so the easiest way to deal with these sorts of questions, because they can be very wordy, they can get quite frustrating, is to make a two-way table. This will really help with the probabilities. So when you're making your two-way tables with this, you want to think to yourself, okay, well the first event was A, and the opposite of A is not A. So we put A and not A above each other. Remember, the dash means not A. And then we've got event B. So B and not B goes next to each other. And then you make your table with these values. Make sure you remember your totals as well. Okay, so A represents on the field and B represents on the bench. So let's put in the numbers that they've given us into their correct spots. That's definitely the first thing you want to do. So we know that there was 5 people that were on the bench and on the field. So 5 can go straight in. We know that there was 13 people that went onto the field. So 13 for the total on the fields. We know that 7 people were on the bench. So 7 goes down there. And we know there's 15 players in total. So when you've got these numbers into the table in their correct spots, then you can jump to completing all values. So you can see here that we filled in all the values. So we can see literally numbers for everything we need. So the first one is considering the probability of B given A. So given that we're in this A row, notice this row is for our A. So we just want to consider this row. So there's a total of 13 here. How many of them were in B? So you can see with these 2 numbers here, which was the amount that was in B as well. So we can see that in B there's 5 out of the 13, if that makes sense. So that's how you get your answer for the probability of B given A. So 5 out of 13. You don't consider these numbers down here at all because you're only given that it's in A. Let's try another one. So the probability of not A given B. So given that we're in the B column, so here's our B column. There's only 7 in this B column. The probability of not A, so notice not A here is these 2. So your answer is going to be 2 out of the 7. So we get this answer right here, 2 out of 7. And lastly, the probability of not B given not A. So look at your not A row. So because we're given that it's not A, what in this row there's only 2 people. What's the chance of getting someone in this row that's not in B? So here's our not B column right here. So it's going to be 0 out of your 2. And 0 out of 2, that's just the same as 0. So hopefully these sorts of strategies will help you out with the questions. Good luck.